Lesson 6.1.2, inverse sine and inverse cosine. Solutions my calculator never told me. Today's lesson we're going to explore a little bit more about the inverse functions for sine and cosine. And you should have a resource page, and if not, it all that it entails is the graph of sine and cosine. We're going to start by sketching the graph of sine of x in your notes. So if you haven't already done that, or if you forget what that looks like, we're going to do it together. And once we have that, we're going to take a look at what the graph of inverse sine looks like. Of course, this is dependent on your knowledge of inverses and how we find them. And you need to remember one key factor from Algebra 2 when finding an inverse. And if that blue graph is y equals sine of x, there was one simple way to find the inverse. And that was to swap x and y, then resolve for y. So in order to get y by itself in this equation, we have to take the inverse sine of both sides. So we have y equals the inverse sine of x. So the same way we were able to switch x and y to obtain the equation for the inverse sine, we are able to do the same thing here on the coordinate plane so that we have the graph for inverse sine. So graph for inverse sine is going to look very similar to the graph of sine, except we're going to, instead of switching the x, y values in the equation like we did over here, we're going to switch the x and y axes so that the curve rotates around the y-axis instead of the x-axis. It is also possible for your calculator to give this to you. So if you have your calculators and you have them handy, take them out, and we'll be able to check out what that graph looks like. As soon as my calculator comes up. Now, looking at the unit circle and talking about inverse sine, the one thing we're going to talk about here is in geometry, when you calculate an inverse sine, when you're finding, say, the missing angle of a particular triangle. So let's say we were talking about a triangle, we had a theta value, and we had, let's say, the hypotenuse was 4, the opposite side was 2. If we had opposite and hypotenuse, we would do sine of theta equal 2 over 4. So we had to do inverse sine to solve for theta, so the inverse sine of 1/2, which would give us an answer for that missing angle theta. Now, because we were talking about triangles, we would get just one answer for that particular value of theta, when in reality there are two values for theta that would result in a side length of 1/2. One of them that we would get there would be 30 degrees. However, who's to say we do not have a triangle in the second quadrant whose angle would be on 150 degrees. And if you type sine of 150 in your calculator, you will also get 1/2. Back to the calculator and trying to get that graph. Something that your calculator doesn't show you, if we go into y1, we type in sine of x, okay? And inverse sine of x. Okay, and we go to zoom 7. We will get a curve, but it's not a whole curve. It doesn't look like a whole curve. It certainly doesn't look like what we drew for the inverse of sine. Now, what's the reason? Well, the main reason here is because the inverse of sine fails a very important test from Algebra 2. And that important test is the vertical line test. Therefore, inverse sine graphed over an entire domain, negative infinity to infinity, is not a function. Your calculator only graphs the part of it that is a function. So you can see here the part of the graph that is a function is graphed. Well, what if we want to see what the whole graph looks like? Okay, well, let's clear that out. And let's go into our just general home screen. We want to go second, draw. We want to scroll down and select draw inverse. And you can do this for any inverse, not just sine. Type in sine of x. Close your parenthesis and hit enter. And what you will see is that whole graph appear. Now we might want to change our window a little bit to go maybe from -2 to 2 on the x-axis. Okay, maybe change y -6 to 6. That way we have 2 pi. There you get that original that the calculator did for us. That is the part of it that's a function. And if we do draw inverse, we will get that whole graph from -2 pi to 2 pi, which is not a function because it fails the vertical line test. Taking a look at number 21, Zach solved the equation sine of x equals √3/2. He explained to Seam that he was undoing the sine function by applying the inverse sine function. Use your calculator to evaluate Zach's answer in radian mode. We're going to do degree mode. Okay, we're going to do degrees there, because the radian mode there will have the pi already factored in. That'll get a little confusing to look at. So make sure the mode of your calculator is in degrees. Okay, and we're doing inverse sine of √3/2. Square roots 3/2, close parenthesis, enter, and we get 60 degrees. However, we should know that for that inverse of sine is positive in more than one quadrant. So that 60 degrees is our quadrant 1 solution. Where else is sine positive? Sine is also positive in quadrant 2. So with a reference angle of 60, the angle we're looking at would be 180 minus 60, which equals 120 degrees. That's our second solution. And again, if you want to check that, go ahead and type in sine of 120. And you should get √3/2, or the equivalent of that. Problem number 22. Talks about cosine. So same process. Let's refer back to our graph. Now to clear this out, you want to go into draw and do number 1, clear draw, and that'll clear our grid. Okay, let's go into y equals and get rid of that because we know it's not going to give us the best picture. Okay, and let's just go ahead and graph the inverse right off the bat. So let's go draw inverse, and we're doing cosine of x. Enter. All right, I got to make sure my mode is back in radians now for this one. My apologies. And we will get that inverse of cosine. So we see again, cosine is also a non-function because it fails the vertical line test. Any vertical line will touch it more than twice. So we're going to restrict the domain so that we can only see the part of it that is a function, which is what your calculator will give you if you were to graph it in the regular graphing mode rather than the draw mode. So for inverse sine, inverse cosine, here's some math notes about that. There are some key features here. We talk about arc sine, arc cosine. That's just another way of saying inverse sine, inverse cosine. Don't confuse inverse sine, okay, with cosecant. They are two different things. Inverse sine is an inverse. Cosecant is a reciprocal. Two different functions. So be careful there. Okay, but what you do need to understand is if you see this notation or you see arc sine, they mean the same thing. Make sure you copy that math notes down in your toolkit. Sketch the graphs of inverse sine, inverse cosine, label them, be sure to record the domain and range of each. Record this information in your toolkit. You can do that. We've already done it together. You can do it on your graphing calculator. or you can use the draw function to graph those inverses. Sketch the unit circle, show where sine of x equals 0.3 by drawing the horizontal line. We should know when we're solving this equation, sine of x equals 0.3. Because this 0.3 here is positive, we should know that there are two solutions. Those solutions will appear in the first and second quadrant because that's where sine is positive. So when we type this into our calculator, we need to get better at this, at knowing what type of answers to expect. Otherwise, we will fall for what our calculator gives us. So inverse sine of 0.3. I come back over here to my calculator. Let's clear that out. Let's make sure I'm in degrees. That way I don't get any funky numbers. And I'm going to do inverse sine of 0.3. And I'm going to get one answer. But I should know by now that that one answer is not the only answer. So I get x to be 17.5 degrees. That is the answer, hopefully, obviously, in the first quadrant. My second answer is in the second quadrant. It has the same reference angle. These two references are the same. But I got to do a little work. Use 180 minus 17.5 will give me this whole angle that I'm in search of. So x could also equal 180 minus 17.5. So what is that? 162.5 degrees. So you have two possible solutions. We got to make sure we're aware of that. And last, we have, what about cosine? Will it always be 180 that we're adding or subtracting to or from? No. That's only for this specific example. Every one will be different. We get tangent, we'll be talking about first and third quadrant. So on and so forth. Here we have cosine of x equals 0.3. So let's first do letter C, where we're finding solutions between 0 and 2 pi. That means we'll have two solutions. So cosine of x equal to 0.3. We're talking about unit circles, so between 0 and 2 pi, cosine is positive in the first and fourth quadrants. So inverse cosine of 0.3 gives me, okay, second inverse cosine 0.3, and I'm going to get 72.5 degrees. Obviously, that is my answer in the first quadrant, 72.5. To give my answer in the fourth quadrant, I'm going to take 360 minus that reference angle. Okay. So my second solution there is fourth quadrant, 360 minus 72.5. And I wind up with a second answer of 287.5. That's all my solutions between 0 and 2 pi. However, if I want to go for all values of x, again, that was the process we talked about today. The equivalent of that, I would have to add an entire 2 pi to it, another 2 pi, and another 2 pi, so on and so forth. So for all values of x, I'd have 72.5 plus 2 pi n. Excuse me. False. Mr. Warner's mistake. Today we were talking radians. Right now we're talking degrees. So let's try to keep this units matching. That's my mistake. It should be 72.5 plus 360 n. Hopefully you can pick that up. 287.5 plus 360 n. Why 360? Because we're talking about degrees, not radians. If it was radians, then it would be 2 pi n.